So this is one of the examples that we're going to go through. So find the coordinates of the non-stationary points of inflection. So this time, slightly different. We want them to not be stationary points. So to find the points that are not stationary, we need to know which points are stationary. So that's our first task. Okay, so to find stationary points, we differentiate and we end up getting 3x squared plus 10x, take away 7. Okay, we want stationary points, so we set our differential as equal to 0. So that means that 3x squared plus 10x take away 7 equals 0. Okay, so we're going to solve that to find our stationary points. So on our normal calculator on the ClassWiz, a bit blurry. So we're using equation and function. Number 2 for polynomial. Degree, the highest power of x is 2. So we've got 3x squared equals, and then 10x equals, and then negative 7 as our constant equals again. Got a decimal which we don't want, so S arrow D. So we end up getting x equals negative 5 plus or minus root 46 all over 3. Okay, if you've got the graphical calculator, menu, equation, execute, F2 for polynomial, can't really see, F2 for polynomial, and then our degree is 2, so you type in 2 and then execute, and then it says how many, it's giving me an x squared, clear, exit, I want degree 2, so how many x squareds? I've got 3 equals, how many x's? 10 equals, my constant is negative 7 equals, then I press equals again, and I get negative 5 plus root 46 over 3, and negative 5 take root 46 over 3. So that's how you do it on your graphical calculator. So now we found our stationary points, so you can write a little, so these are our stationary points. So now we need to find our points of inflection. So at a point of inflection, we know that the second differential is equal to 0. So we need to find the second differential first. So the second differential, wait for it to stop being blurry. So 3 times 2 gives us 6x plus 10. We want it to equal 0. So that means that 6x plus 10 equals 0, which means that 6x equals negative 10, which means that x equals negative 5 over 3. Okay, but like we said in one of the initial videos about points of inflection, just finding the x value isn't actually good enough. You need to check your second derivative either side of that point. So this is negative 1.6 recurring. So we're going to check one value either side of negative 1.6 recurring. So when x equals negative 1.7, then our second differential is equal to, so negative 1.7, so 6 times negative 1.7 plus 10 equals negative 0.2. which is less than 0. So less than 0, so that means this is concave. And then we're going to try a value that's greater than x equals negative 1.6 recurring, so negative 1.6. Our second differential, so this time 6 times negative 1.6 plus 10 equals 0.4. So 0.4, which is greater than 0, which is convex. So we've gone from concave to convex, so we know that somewhere in between there must be a point of inflection because we've had a sign change of our second differential. So we know for definite there's a point of inflection when x is equal to negative 5.3. So as you don't need to write this, but it's just good practice to kind of explain what you're doing. So as our second differential changes sign either side of negative 5/3, we have a point of inflection. Okay, but we haven't finished the question. The question actually said you need to find the coordinates. So when x equals negative 5/3, y equals, then we've got to sub it back in, so negative 5/3 all cubed, add 5 lots of negative 5/3 squared, take away 7 lots of negative 5/3, take away 2. So that means that y is equal to 511/27. Sorry. Okay. Final statement. Hence, the point of inflection is at negative 5/3, 511/27.